Okay, we're going to work on solving a system of linear inequalities in this example. And you can see we get to have a nice little story problem to go along with it. How nice is that? All right, so we have Malcolm. Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. So he's got these two different jobs. His goal is to earn at least $200 each week, but he can only work a maximum of 20 hours per week. Malcolm must spend at least 5 hours per week walking his neighbor's dog. So he has that commitment. For how many hours should Malcolm work at each job in order to meet his goals? So his goal is to earn at least $200 each week, but he has to make sure 5 of the hours he works are dedicated to walking the dogs. So our first step is we're going to define the variables. What do we want things to equal? So we're going to let x equal, what we're trying to figure out is how many hours should he mow the lawn? How many hours should he walk dogs? So we'll let x equal the number of hours that he spends mowing lawns. And we're going to let y equal the number of hours that he spends walking dogs. Okay, now we're going to write some inequalities to model the constraints. And you'll see when this is graphed kind of why the word constraint is being used. But we know that his goal is to earn at least $200 each week. So if we think about what that looks like, he is earning money mowing lawns. He's getting $20 times every hour that he mows lawns. In addition to that, he's making money walking dogs. He's getting $10 for every hour that he walks dogs, and he wants this to be at least $200. So that means $200 or more. So we're going to say greater than or equal to 200. So there's our first inequality. The other thing we know is that he can only work a maximum of 20 hours per week. So we're going to have a second equation. The number of hours he spends mowing plus the number of hours that he walks the dogs cannot go over 24 or 20 hours in a week. That's his maximum. So that's going to be less than or equal to 20 hours. And the last thing we have is he must spend at least 5 hours per week walking his neighbor's dogs. So that's going to be a constraint on our y variable. However many hours he spends walking the dog, it has to be at least 5 hours a week. So y, which represents the number of hours walking dogs, has to be greater than or equal to 5. Okay, we are going to graph those three inequalities and kind of see how this takes shape and understand how we can answer the question from that. So our first inequality is 20x plus 10y is greater than or equal to 200. To graph this, we are going to solve this for y. Let's get the x to the other side where we want it. We're going to subtract 20x from both sides. 10y is greater than or equal to, we're going to write the x term first so it's easier for us to graph, negative 20x plus 200. Now to get the y alone, let's go ahead and divide every term by 10. So we have y is greater than or equal to negative 20 divided by 10 is negative 2x plus 200 divided by 10 is 20. So this we are going to graph. It has a y-intercept of 20 and a slope of negative 2. So if we look at our graph, we're going to start by plotting the y-intercept at 20, and then the slope is negative 2. So we're going to go down 2 to the right 1. And we are just going to plot all those slope points. Because this is a greater than or equal to, this will be a solid line. We'll see if we get into situations where we might draw a dotted line. But there's our first equation. It does say that y is greater than or equal to. So graphs like this would involve shading. You're either going to shade above the line or below the line. If it's a greater than or equal to, then we are going to shade above this line. So I'm just going to put in some arrows as markers knowing that the shading is going to happen above that line. Our next equation that we're going to graph, I'll go ahead and do the work over here. This one's a little bit easier. X plus y is less than or equal to 20. Solving for y, all we have to do is subtract x from both sides. So y is less than or equal to negative x plus 20. So we're going to graph this. We have the y-intercept up at 20 again. And this time the slope, it says negative x. So just a reminder, that is a slope of negative 1. So here's our negative 20. Slope of negative 1 is down 1 to the right 1. And once we get all those points plotted, we can draw in that line. And this time it says y is less than or equal to. So less than means we would shade below the line. So I'm going to put some arrows to indicate the shading will be below the line. And then the last line that we have to graph was that y is greater than or equal to 5. If you're graphing a line that does not have an x, it just has the y, this is a horizontal line. It's a horizontal line at 5. So I'll go ahead and draw in a horizontal line at 5. And it says that y is greater than or equal to 5. So we are going to shade above this line. So what we've created is a region that has shading from all 3 lines pointing toward it. And we are going to shade in that region that we see. Everything we're shading in here, kind of this middle triangular section, these are all solutions to this inequality. Solutions where Malcolm could earn at least $200 in a week, but he's also managing to fit in the 5 hours of walking the dog. So for example, so this is our, by the way, this is our answer right here. The shaded region are all of our solutions, but we could be more specific and say, let's look at the ordered pair, I don't know, 10, 6. 10, 6 is right here. Because that's in the shaded region, that means he could mow his lawn, or he could mow lawns for 10 hours. He could walk dogs for 6 hours. And he's still meeting his goals of at least $200 a week and spending at least 5 hours walking his neighbor's dog in a week. So any ordered pair in this shaded region would satisfy what he's looking to do.